This is a very common question type on college entrance exams, and basically, as we state on the thumbnail, it can be solved by inspection, even though it looks absolutely horrific. There are two clues which tell us that we can solve it by this method. First of all, we have here the limit between 0 plus something and 0 minus something. That's the first clue. And the second clue is that when we look at this combination of functions here, every single one of the functions within it is either even or odd, and that's leading us to hope that basically if the overall expression is odd and we have the integral between minus a and a being anything, of an odd function dx, then the integral is 0. And we'll go back to this in a minute and explain it in a minute. But for those who can't wait, assuming that this entire expression here is odd, and we will explain it later, but assuming that it is, we basically have, because we have here pi and minus pi, so we're around the point 0, the integral between pi and minus pi of 1 add this odd function here, dx, equals the integral between minus pi and pi of 1 dx, add the integral between pi and minus pi of our odd function dx here, and we've just explained that or we will explain that is equal to 0, and so it becomes equal to the integral between minus pi and pi of 1 dx add 0, which equals x between pi and minus pi, which equals 2 pi. So the answer to this entire thing here is 2 pi. As we stated, we have solved it by inspection. Okay, so now let's move a step backwards and go back into a little bit more detail what's going on. Okay, so as a reminder, an even function is symmetrical about the y-axis. Okay, so for example, and I'm probably not going to draw these curves very well, y equals x squared here. Well, that's not too bad. Y equals x squared is an even function because it's symmetrical about the y-axis. Now, an odd function is symmetrical about the point, about the origin. So let's say, for example, y equals x here is symmetrical about the origin, which basically means that everything here is mirrored here and everything here is mirrored here. Okay, now, if we look at our odd function again, let's have another look at our odd function. It doesn't matter what the odd function is, but let's say, for example, y equals x here. We can see why our trick works, because if we integrate between minus a and a, then we have this area here and we have this area here, and when we sum up the whole area, this area, no matter what the function is, as long as it's odd, exactly cancels out this area, so the integral between minus a and a of our odd function dx will always be equal to 0. So the question now becomes, now that we've understood that, how do we know that this thing here is odd? Okay, so basically let's have a look at that. So first of all, we need to know some basics of even and odd functions. Okay, so an even function times an even function, or an odd function times an odd function, is equal to an even function. An even function times an odd function is an odd function. An even function over an even function, or an odd function over an odd function, is an even function. And when we have an even over an odd, or an odd over an even, we get an odd function. So basically E is even and O is odd. Sorry, just in case O is not 0, it's odd. Now, as long as you know these, and there is a relatively easy way to remember all of these actually. If you remember that y equals x squared is an even function and y equals x is an odd function, and then if you wanted to, for example, multiply even by even, well, x squared times x squared is x to the 4, which is an even function, which is that one. Y equals x, well, x times x is x squared, which is an even function, so odd times odd is even. Even times odd, well, x squared times x is x cubed, which is an odd function. Even over even, well, x squared over x squared, or x to the 4 over x squared is an even function. X cubed over x, the two odd functions, is an even function. And if we had, for example, x squared over x, which is even over odd, that equals x, which is odd. So you can actually work these out just by using the even function y equals x squared and the odd function y equals x. Just a little trick to remember them. Okay, so basically, let's have a look at our function again. Let's just write it down again here. So we had, what did we have? We had the integral between pi and minus pi of 1 dx. That's a bit we've already worked out. Add the integral between minus pi and pi of cos cubed x sec squared x sine cubed x dx over root 2 add x to the 4. And what we need to do is we need to establish why is it that this thing here is odd. Okay, well, we know that, let's take them one by one. We know that cos x is even because cos x looks like this, like that, so it is symmetrical about the y-axis. So cos x is even, which means that cos x times cos x, even times even, is even, which means cos x times cos x times cos x is even. So we know that that bit there is even. Now sec x is basically 1 over cos, and as cos is even, well then sec 1 over cos is also even, so therefore sec squared is even because sec times sec, even times even, is even. So we know that this one here is even. Let's have a look at the 2 plus x to the 4. Well, 2 plus x to the 4 is basically something along the lines of that, which again is symmetrical about the y-axis, and the square root of it will be slightly more more flat, but it's still going to be even. So we know that this here is even. And let's finally have a look at sine x. So we have sine x is basically like that. That's sine x, which clearly is odd because this bit and this bit are symmetrical and identical, and it's symmetrical around the origin. So we know that sine x is odd. This is the interesting one. Now, odd times odd, sine x times sine x, odd times odd, we've already established here, odd times odd, is actually even. So sine x times sine x is even, but so therefore sine cubed x is odd, because it's basically sine squared, which is even, times sine, which is odd, and even times odd is odd. So basically, when we look at this here, we have even times odd over even. So we have even times odd over even. And basically, even times odd over even, well, even times even is even, so that gives us even times odd over even, and even times odd is odd, which gives us odd over even, which gives us odd. So therefore, by looking at each one of these, we have established that the entire function here is odd, and therefore, as that's odd, and we are integrating between 2 points either side of the origin, then we know that that integral is equal to 0. Now, just a matter of interest, I'm using courtesydesmos.com here. This is actually the function y equals cos cubed x sec squared x sine cubed x over root 1 add x to the 4. You certainly wouldn't want to have to work it out. 2 add x to the 4. You certainly wouldn't want to have to work it out yourself. But you can see that it is an odd function because this area here exactly offsets this area here, and this area here exactly offsets this area here. So it's not just a theory, it does work, and the integral is equal to 0. Okay, so basically, if you ever see a horrific looking integral like this, which is full of odd or even functions, either on its own or next to a simple integral that you can split into 2 integrals, and the limits are between some point either side of the origin, equidistant from the origin, then think about this video, and it is likely that the function will end up being odd and the integral will be 0, leaving you with either 0 or a very simple integral indeed to do. Okay, well, I hope you found this useful. If you do get this on an exam, and there are quite a few of these questions, then hope you get it done straight away, save you a little bit of time. If you like this video, please press the little thumbs up button and subscribe to the Gresty Academy YouTube channel. Thank you.